Okay, in this problem B, we're pulling from problem 790, in which we had a function that was v of x equals x squared times the quantity 12 minus 4x. So we're using a different function this time, but we're still finding different slope values. So in looking at this problem, we want to find 4 different slope values, and we could do it using the slope expression y2 minus y1 over x2 minus x1. But since you have to know how to use the AROC expression for your test, I'm going to show you how to use that here. The first thing that we want to think about is when we have these intervals, we're actually talking about different h values. So in this first one, from 2 to 2.5, the h value is 0.5 because that's the change in the x's. For II, or number 2, we're going from 2 to 2.1, so the h value is equal to 0.1. For 3, we're going from 2 to 2.01, so the h value is equal to 0.01. And for 4, we're getting even smaller interval, where the h value is equal to 0.001. And so we could, like I said, calculate 4 different slope expressions for this, but we're just going to do one slope expression using the AROC expression, which is f of a plus h minus f of a all over h. In this case, we're starting our first x value, and all of these is 2. And so 2 is our a value. And so that's going to go in place of a here and here. And then we just need to plug 2 plus h into our original function. So f of 2 plus h is going to look like this. We're going to plug it into this x. So 2 plus h squared times 12 minus, there's another x there that we're going to plug it in for, 2 plus h. That's going to be fun to simplify. And then we're going to plug 2 into the expression to get f of a, which is this part. So 2 squared times 12 minus 4 times 2. Okay, and then we're going to put that all over h. Let's start with the easiest one. 2 squared is 4. 4 times 2 is 8, so 12 minus 8 is 4. 4 times 4 is 16. I'm going to write it right here for now. And then we need to worry about simplifying this other problem. So we can start with this, the 2 plus h squared. 2 and h, and 2 and h, we have 4, 2h, and h squared. So that becomes h squared plus 4h plus 4. And then we need to multiply that times the second set of parentheses here. So if we start inside, we have minus 8 minus 4h, and we have a 12 out here. So 12 minus 8 is 4 minus 4h. And when we need to multiply this, it's going to give us a giant area model. So looks something like this. I'm going to have 4 minus 4h here, h squared, 4h, and 4 here. When we do all the multiplying, oh boy, 4h squared minus 4h cubed, 16h minus 16h squared, 16 minus 16h. And if we write that out, we have I'm going to use a different color here. Negative 4h cubed. And then 4h squared minus 16h squared is going to be minus 12h squared. 16h minus 16h is just gone, plus 16. And then we saw from our expression up here that we had minus 16. We have all of this over h. Let's see, it's getting better. So the 16s cancel out, and we have an h in every term that's left, so we can get rid of one here and make this squared, get rid of that one, get rid of that one. Our final expression is negative 4h squared minus 12h. Now, how do we use that to help us? Now we can just plug in our h values to get our outputs.